Greetings and welcome to today's session of Tungsten University. Today's topic is going to be what the value proposition is for continuent tungsten clustering. What does that mean exactly? We're going to talk about what clustering does and specifically what business needs does it address. Here, we address two key areas of business operations, availability and scalability. And under the availability category, let's look at some of the key business questions that we're going to cover today. What happens to your business if your database goes down? What is the impact to your staff, your customers, your reputation? What happens? What is the overall cost to your business? How long does it take you to get back up and running? How much data will you be able to recover? And what staffing do you need to have on hand to address this sort of task, especially in an emergency? Less critical, but no less important, is scalability. As your business grows, what is the customer experience when they need to interact with the database? If your application requires data for the customer experience on the front end, they're interacting with the database. If your traffic grows, the number of customers increase, but the database does not, things may slow down over time. So how can you position your business to handle growth gracefully? And as you grow, not just in quantity, but in geographic area, perhaps you now have customers worldwide, all over the globe, where perhaps you just started in one small area. You need to put your data where your customers are. How do you do that? How do you keep it in sync? And finally, if I have to spend money on infrastructure, on technology, how do I use my money the best way possible? What is the most efficient spend and the most efficient utilization of my resources? So these are the topics we're going to cover today. Again, availability, how do you make sure your database is up? And scalability, how do you make sure your database grows with your business? And so let's start with a very, very quick introduction to clustering. Tungsten specifically, tungsten clustering is all about having multiple nodes and moving the right primary to another node if there is a problem. And we do this automatically in the event of a failure. We can do it manually, invoked by a human, if you would like to do maintenance. And if we're round robin doing reads from replicas, we can do that automatically. And the key to all of this is what we call the connector, that intelligent proxy, which always knows about the state of the cluster because our managers are always communicating that state to the connectors. And when there's a problem, our managers will communicate that and the connectors will reroute traffic. So that's how we deal with clustering in a nutshell. Let's get a little tiny bit more detail on that. And note that there's really only three components necessary for tungsten clustering to work. First off, we use a Linux operating system as our base. You can install that bare metal on VMs, cloud instances, and we are very operating system agnostic. As long as it's got a Linux root, we can run on it. We have a full list of which operating systems we test on our website under the documentation. And so the philosophy here is that one node in our cluster handles the writes. There's one node called the primary, which is responsible for writing the data that comes from application requests. And the rest of the nodes are called replicas, and they get copies of the data, and the copies of the data are provided by the tungsten replicator component, which also lives on each node. So by putting all three of these components together in a tightly coupled system, the replicator moves write events from the primary to the replicas. The manager health checks the cluster and provides command and control. And the connectors are the secret sauce, which allows the application traffic to always be routed or directed to the proper database node for whatever operation it needs. For example, a write goes to the primary. Reads can either go to the primary or to one of the replicas, and that's with the optional read-write splitting enabled. And lastly, there are two types of clusters. Typically, we have what we call a standalone or local cluster that has three nodes to start with. It can grow. And we also have something called a global or composite cluster, which is just a cluster of clusters, multiple three-node clusters joined together with tungsten replicator, and that's capable of spanning data centers, regions, and going worldwide. So you can have these clusters joined together, managed as one, but running in different data centers and regions all over the world. So as we proceed, we're going to just take a quick look at the differences between a local cluster and a global cluster. You've already seen the picture for a local cluster, and so just please note that you can install tungsten clustering on basic MySQL. You should not need to change your application at all. And by doing so, you'll get automatic failover and optional read-write splitting, and you can have all of that working with, again, no application changes. If you would like to span data centers or regions, then we can create composite cluster of clusters. You can place these three-node clusters anywhere you like, and they are joined together by asynchronous replication. All tungsten replication operations are asynchronous, which gives them a great amount of resiliency in the event of a network problem, where they will automatically pick up where they left off when the network connectivity is restored. When we perform today's demonstration, we will use this particular setup or topology in our demonstration. Here we'll have two three-node clusters, one in region East and one in region West. There will be one single writable primary amongst all of the nodes, and it will be joined by efficient one-way replication. And note that there's a single replication stream going between the clusters, which is then distributed by the relay node for efficiency when it gets to the remote cluster, so that we are not clogging up the network with too much replication traffic. So let's start to look at the business questions and how tungsten clustering actually solves all of these problems. This is the true value proposition of tungsten clustering. The fact that we can provide continuous MySQL operations for your business. Let's look at how tungsten clustering does that. Because we provide availability, tungsten will keep your downtime to an absolute minimum. If there's a failure, we'll automatically heal it by moving the right primary to another node so that your client traffic can continue to function. And we do this behind the scenes so that you don't have to scramble to recover. This is the core of the value of tungsten clustering, that it is always there watching behind the scenes to make sure your database stays up and your business keeps running. Additionally, because it's in this always on mode, this failure recovery happens very quickly. So when we ask the question, how long is it going to take me to get my database back up and running? When using tungsten clustering, it's often a matter of seconds. When doing a human manual recovery, it could be hours or days even before a full recovery is in place. And so not only can tungsten do this automatically to handle failures, but we can also do it manually to enable all of your maintenance operations to not require downtime as well. So this gives you, while not a critical failure metric for recovery, it gives you a vast amount of freedom to perform day-to-day operations without interruption of service. Then, in the event of a failure, if you had a catastrophic failure of your database, how much data do you get back based on your recovery method? Do you need to go to a backup and restore it? How long ago did you take that backup? How much data have you lost? And so with tungsten clustering, because we keep more than one copy of your data, we are able to switch to another copy, which is, for the most part, 100% up to date, and continue operating as if nothing happened. So there is very little to any data loss. Under normal conditions, there is zero data loss. Under certain catastrophic conditions, there is a tiny, tiny window of data loss that comes with asynchronous replication. What we have found with our customers over the past 10 years is there have been extraordinarily few incidents of data loss, so much so that we are highly confident in continuing to sell our product into enterprise environments where data integrity is essential. And so, lastly, let's look at how many people of what skill level do I need to accomplish this? Well, once it's installed, it becomes infrastructure type software. And so, in in many cases, a failover can happen, operations continue, and a recovery can be as simple as a single command in a GUI, which I'm actually going to demonstrate to you in a few slides. So it will significantly reduce the time and staffing necessary to maintain your databases, or your staff can spend their time doing other things of greater value to your business. And so the other point is scalability, right? We are keeping your database up and running. Now, let's make sure that it is also able to grow to match your business needs as your business grows and your traffic increases. So we have two different ways to look at this. The first is if I'm going to grow to a set of users in a geographically separated locale, for example, I have users in the United States and I have users in Australia and users in London and users in Brazil. And so we have data centers or cloud regions in each of those areas. How am I able to spread my database in a timely fashion so that customers all over the world can see the same copy of the data but still be served in a rapid manner so that they are not degraded by distance, the latency of the request to make their user experience just too slow to be of any use and they become unhappy. So we want happy customers with fast applications and a very rapid response from the database. And we do this by placing the data where the customers are. So we'll get a copy, a replica of the database into their region. And then our connectors, because they are intelligent proxies, are able to actually direct reads to local replicas in that particular region. So that means that users in Brazil or users in Australia are able to get a quick read off a local replica and have a good, happy experience at the user application interface layer. Right? This is critical to be able to grow your business. Additionally, we have many options to choose from in terms of architecture or topology, where you can have all of your rights go back to one central location, or you can have your rights occur in the local region and be synchronized in a mesh so that rights to one site will be replicated to all other sites. It's a more complex topology requiring more application awareness because you're going to do active rights. However, we can work with you to ensure that your applications are able to accomplish this well. Also, to further this concept of read-write splitting, when having local rights, not only can we do that on a regional basis, but we can, of course, do that on a local basis so that we can put writes onto a local replica, offloading them from the primary, increasing write performance, as well as we have the ability to increase our node count so we can add replicas to support additional read traffic. So in two different ways, we address scalability. On the local level, by read-write splitting and potentially adding additional read replicas, and on the global level, by directing reads to the local region and potentially also directing writes to the local region. So now that we've looked at how tungsten clustering addresses the various business needs, let's just drill down a little bit into each of those two topics and finally head into the demonstration of how all of this is addressed. So let's start with availability. A few specific points to note is again, we move writes and reads to another node in the event of a failure. And that we have two different phrases or labels for that. High availability, which we consider availability within a single data center site or region, so across those three or more nodes. And global availability, which we call disaster recovery, And we tend to think of that as spanning data centers, sites, regions, even cloud providers, right? So if we have a local failure on a single node, we move to another node. If we lose the entire site, then we can move to another region. So a failure in a node, high availability; a failure of a site, disaster recovery. And so we handle that in two ways: automatically and manually. And for the most part, you're completely covered in terms of uh, automatic failover. So let's look at that quickly but carefully. Tungsten clustering will handle local failovers automatically, period. You can confidently deploy tungsten clustering and know that each local cluster is protected from a failure. If you lose the node, we'll switch over. We'll have a failover. If MySQL crashes, we'll have a failover. The data will continue to flow. And because our connectors are so intelligent, when dealing with certain global topologies, composite active-active and dynamic active-active, we have automatic global failover in the case of the loss of entire site. Manual availability comes typically when we want to invoke a switch. So in the tungsten world, we talk about two different words, two different actions, two different operations. The first one is a failover, the automatic movement of the roles to another physical node, and a switch, which is the human invoked movement of a role to another node, typically the primary, right? So we want to be able to move the right role, the ability to handle writes, called the primary, to another physical host. And so again, we do that automatically. It's called a failover. And if we're doing that manually, it's called a switch. And so when we do a local switch, we just move to another node in the same cluster. We can also do a global switch, which means I want to move the right primary to another node in an entirely different cluster, potentially somewhere else on the planet. So it is with a single command that I can manually switch write operations from one cluster to another. We have many customers who will do that once a month. For disaster recovery testing, they'll simply move the right primary over to another data center. So just briefly, let's talk about the topologies here so that we can understand the differences. Again, we have what we call the composite active-passive, which means that there's one writable node amongst all of the clusters worldwide. All of the rest of the clusters are read-only passive, and all writes are sent back to that single primary. So when we talk about switching or failing over the role of the primary, we're talking about moving this write role to this cluster, and then this primary will become a relay in place. So we have other topologies like composite active-active, where writes are occurring in both clusters at the same time, and we're replicating in multiple directions. Two bidirectionally here because we only have two clusters, but if you added a third, it would become a mesh, or a fourth, it would become a mesh because every cluster replicates from every other cluster. We have other more complex topologies called dynamic active-active. And while both sites are capable of writes, we direct all of the writes through the connectors to a single primary. This makes the use by the application much easier because all rights are being handled in a single place. So conflict resolution from active-active is minimized because all the rights are occurring on a single database node. This is what we call the best of both worlds because the original topology, composite active passive, there is no automatic failover between sites. That was done deliberately to prevent flapping. And so our customers have asked over time for the ability to have simple adoption, meaning no multiple rights that need to be resolved, just all rights in one place, but automatic failover should the site be lost. And so ultimately, we've come up with this blended topology called dynamic active-active, which gives all of the above, the best of all worlds, and it is very popular and successful. And so we have discussed the different types of availability. We have automatic and manual availability and disaster recovery. And now let's look at that in light of scalability. So now we know that we can have multiple clusters worldwide. And so we can either perform writes at a single site as discussed and replicate those outwards, or writes at multiple sites and replicate them as a mesh. And so we can provide all of that all over the world. And then by doing read-write splitting, we can offload reads from the primary, making writes more performant because they're not fighting for resources with the reads. And as stated earlier, we can always add additional nodes per cluster to increase read performance. And so finally, let's have the demonstration. This is the fun part. Let's show the following things. I have written a small demo application that's just going to show us a read request and a write request and to which host they have landed. And we are going to use a composite active passive 6-node cluster, 3 nodes in east, DB1, DB2, and DB3, and 3 nodes in west, DB4, DB5, and DB6. Currently, DB1 is the primary and DB4 is the relay. And so our demo application is going to be running here on the apps, talking through the connector and landing on one of these 6 nodes. We expect all of the writes to land on the primary and reads to land in the local clusters. So again, if I put in a read request in east, I expect it's going to land on either DB2 or DB3. If I put in a read request in west, I expect it's going to land on DB5 or DB6. We're going to round robin those reads. As a side note, if no replicas are available, reads will come from the primary. So we will always serve reads, even if the replica is unavailable. And writes, of course, will be directed to the lone primary on DB1. And so it's that primary role on DB1 that's going to be moving around as we do our demonstration. So the first thing we're going to show is a local switch where we're going to manually ask the cluster to move the primary role to a different node. Then we're going to manually ask the cluster to move the primary role to a different node in a different cluster. So the first one we're going to do in the local cluster. The second one we're going to move to an entirely different cluster from east to west. Then we're going to demonstrate kicking out the plug from the MySQL server. Actually, it will just stop the process and watch what happens as it does an automatic failover to another node in the same cluster. And finally, we'll show the one-step recovery through the GUI. And so without further ado, let's do the demo. And here we have a total of 6 nodes. Let's quickly take a look at those. DB1, DB2, and DB3 in the east on the top, DBs 4, 5, and 6 in west on the bottom. And I have our little demo app running on each of the nodes and talking through the connector. And what we're doing is just asking where the writes and reads are occurring every 1 second in a loop. And you can see, if we look carefully, that we are indeed round robining. Here is a DB3 and a DB2 and some DB2s, some more DB3s. They're somewhat random. And you'll see DB4 and DB5, DB6, DB4. So we're round robining, and there's a little bit of load occurring. And so this is normal operations for the cluster. And we can also take a look at the Tungsten dashboard GUI, which is showing us the same information. Here is the global composite active passive cluster represented. Down below, we have the east and west clusters with the 3 nodes each, and we can clearly see the primary and relay nodes. And it's the primary that we want to watch carefully as it moves around, as we do things. And so the first experiment that we'd like to try is, how easy is it for a human being to tell the cluster to move that primary role? And what is the impact on the applications as we do that? So what I'm going to do is I'm just going to come over to the command line because this is the most educational. I'm going to run the cctrl command, cluster control. And here we are in the cluster. And I'm going to simply give it a single command called switch. That is all. And so we can watch the upper left window as the cluster control command works through the steps to perform that switch. And you can watch the loops and see if anything hangs during the operation. And this is the key, right? We want to see that the application continues to work after just a brief pause. And so let's try it. Also, you can watch on the right side in the dashboard as different things go into different error states and move around. Here we go. So if you notice, this loop right here is just sitting there and waiting. It's not progressing. Oop, but then it just moved on, and it moved as soon as the new master came online. So that was what, approximately 3 seconds? And so within 3 seconds, we did movement of the primary. We had a brief pause on the application, and then it continued to function. And over here in the dashboard, and up here in the upper left window, you could see that we continued to rejigger all of the roles and pointers within the cluster so that now DB2 in East is the new primary, and all of the other cluster members are pointing properly to it. This is something that would take a human administrator quite a bit of time if each individual MySQL server had to be repointed, had to have their master changed, and so forth. But the cluster software does it automatically for you. So this reduces total cost of ownership because admin time is so much less and so much easier. It can be done through a GUI. So again, we've converted hours of effort into 3 seconds. So that was simply a manual switch. And now our primary is on DB2 in the local cluster. Let's extend that concept and just move the primary over to the West cluster. And let's see how easily or difficult that might be. So I'm going to get out of cluster control. And I'm actually going to get back into it in a special mode called -multi, which lets me work on the entire cluster at once. And as you can see, I have access to the parent global as well as East and West. And I want to use the parent global where we can see that we have East as the composite primary and West as the composite replica. So East is active, West is passive. And again, I'm going to manually issue that single switch command. We're going to watch both in the dashboard to see what happens, as well as the activity of the applications as that right primary moves. Let's give it a try. So we've invoked the switch. We'll keep an eye, say, over here to see how long this takes. Maybe start counting. 3, 4, 5, 6, 7, 8. So 7 to 8 seconds. We had a pause, and now we have literally moved the right primary across the globe to an entirely different site with just a brief 7-second pause from the application perspective that the customer sees. And now all of the writes are occurring on DB4 in the West region. So it's literally that simple to flex the cluster, to admin the cluster, to see what's happening, and to enable this sort of maintenance and testing to occur with no effort at all. And so if we look back at our agenda, we have done the app demonstration. We have shown both a local and site level switch. Now let's demonstrate a failure. What happens if I shut down MySQL on DB4? So let's do that. Let's shut down MySQL on DB4. So let's go over to host DB4, sudo service MySQLD stop. Okay, so we're going to watch again for what happens to the application, and we're going to watch what happens to the right primary on DB4. Here we go. And also keep count of how long it takes. So we've invoked the failure. 1, 2, 3. Notice we're hung here trying to access the database, and there was about 4 seconds. We were back. Note that failovers are actually faster than switches. Well, why is that? Switches are graceful. Failovers are not. And so with a switch, we will wait for all in-flight events to complete so that we may gracefully treat the customer requests. Right? We don't just kill them. So we take a few extra seconds to let everything finish. That's why a manual switch is slower. A failover, well, all of the in-flight stuff just died. So we don't care to wait. We're going to move immediately. And so a failover will actually be faster than a switch. And so one other thing to note is that we talked about data loss window earlier. And so tungsten clustering has a lot of mechanisms designed to prevent data loss. And here you can clearly see one of them in operation. So please note that because we read from the MySQL server binary logs, which exist on disk, I killed the process. But just because the MySQL server process died doesn't mean that we can no longer read the bin logs. In fact, we can and we do. So as we're doing the failover, we continue to read the binary logs, any last events that got written, and make sure that they are transferred to the new primary after the failover. And that's why we say bin log fully read. And that tells us that there was no data loss for this failover. So tungsten protects your data integrity as well as your availability. And last but not least, let's show just how easy it is to recover a cluster with just a single command. And this time I'm just going to do it from the GUI. I'm just going to come here, cluster operations, recover. We don't get quite as much information as we do on the command line, but we do get a nice blue banner showing us what's in progress. And as soon as it completes, it'll turn green and let us know that we're done. Recover can take a little bit longer, and oop, there we go. And so we know that the previous primary DB4, which was previously offline, is now back online and has been converted properly to a replica, is slightly behind on its replication. So now let's turn refresh back on, and it is fully caught up. And so recovery is just that simple. The tungsten cluster manager went out. It saw that the database server was stopped, started it back up again, converted all the roles, made sure everything was lined up properly in terms of sequence number, and off we go. And we have a fully healthy, healed, and viable cluster to work with, keeping your business up and running. So that's the demo for today. As as I hope you've enjoyed it, we can quickly summarize the tungsten benefits. We have significant availability, load balancing, geoscaling. We can use off-the-shelf MySQL. We have great replication. We can span clouds, super easy to manage, the best 24/7 support anywhere. And really, if you think about it, the value provided, it really means it's the lowest total cost of ownership of any database software out there. And we can easily provide customer references to prove that. In this deck are summaries of all the key benefits. And as we wrap up, please note that we believe that primary replica clustering, it's the cat's meow. This is the way to go. This is what protects billions of dollars of enterprise every day, and it can protect your business too. We have a lot of documentation and resources at docs.continuent.com, blog posts, at continuent.com/blog. Please check them out. Don't hesitate to reach out to any of us. We are very happy to get together with you and talk over any of your questions, provide free training, whatever you need to get comfortable with the tungsten clustering concepts and product. Thank you very much. It's been a pleasure speaking with you today. This is Eric, and we will talk to you soon. Take care now.